Welcome to Year 1 Mechanics, Chapter 9.5. This is the last lesson about the SUVAT, about kinematics, about constant acceleration, where we actually will continue looking into it in Year 2 Mechanics. But for now, this will be the last chapter on the SUVAT. So famously, when Apollo 15 landed on the moon, astronaut David Scott conducted a famous demonstration in which a hammer and a feather, you would imagine a hammer will be a lot heavier than a feather, were released at the same time. As anticipated, they hit the ground at the same time. Now, why is that the case on the moon but not on the Earth? Because on the moon there's no air resistance, where on Earth there is air resistance. Therefore, the acceleration under gravity, regardless of the mass, is constant. So when you think of it essentially on the moon, when you drop a heavy man and drop a baby, I don't know why would someone drop a baby, okay, or drop a pizza, which is even worse. You never drop pizza, you eat a pizza, you never drop pizza. They all fall at the same time. Same time, given that they are driven at the same height from the ground, and they drop and they will reach the ground at the same height at the same time. So the acceleration due to gravity in mechanics, in maths, we use 9.8 constantly, okay, consistently, 9.8. I know in physics you might use 9.81, but in maths, mechanics, we use 9.8. Sometimes we use 10 as well. Okay, the question will tell you whether they want to use 10. Annoyingly, if you do use 9.8, you'll get a wrong answer. So do read the question carefully. But most cases, we'll be using 9.8 in maths and mechanics. Okay. One thing I do want to mention in here at the greatest height, as a note, okay, greatest height, the velocity. Sorry, at greatest height, at the greatest height, the velocity is 0 meter per second. I'll explain that in the example below. Okay, right. So, one more thing I do want to mention, acceleration. So when a ball is being thrown, let's say going up, being thrown up, okay, then the acceleration is negative 9.8. It's negative because it's decelerating, right? As you travel upwards, the ball is decelerating. When you're dropping, the ball should be up there, shouldn't it? When you're dropping the ball, okay, the acceleration will be positive 9.8 because the ball is accelerating, right, towards the ground. So anyway, example in here, a ball B is projected from a point O. So let's call this point O, and there's a ball B, okay, travel upwards, okay, with speed 12 meter per second. Find the greatest height B can reach. So let's call this the greatest point G, okay, greatest height is G. Okay, then the ball will come back down. Right, so we want to make a SUVAT from O to G. Okay, couple of things we do want to look in here. Let's fill up the table together. So S, greatest height is measured in meters. Meters has the same unit as displacement, so you can imagine we are measuring displacement. Initial velocity, 12. Now, final velocity in this case is 0 because G is the greatest height. Now, if you're struggling to understand why, why velocity will become 0 at that point, now you can go back to my previous video on 9.3, okay, where we look into the signs of velocity, when is it positive, when is it negative. Now, if you look at here, the velocity, when you travel up, is positive, but when you travel down, is negative. What does that mean? That means during the transition between going up and going down, which is at the highest point, where there is instantaneously at rest, then the velocity is 0. Because think of it, from a positive number to negative number, you must pass through the number 0. So when we say instantaneously at rest, it doesn't mean the ball gonna hold up in the midair, for X seconds. It just means there is a short moment, a brief moment, a blast of moment where the ball essentially just pausing there and come back down. So at that greatest height, the velocity is 0. That's what we're measuring in here. Okay, so G is the greatest height, velocity is 0. It could be the initial velocity if we're dropping the ball. Okay, but otherwise B is 0. Okay, at the greatest height. So remember that greatest height, this will come back in year 2 mechanics. A, acceleration is negative 9.8. So why is it negative? Well, the ball goes up. I know it goes up is negative because what you said just now, throwing up is negative. But surely the ball drops, comes back down. It'll be positive, no? Because the ball will be accelerating. The issue in here is we can't make it positive. Now, we can only make it either positive or negative, right? We can't make it positive because if the ball, okay, is positive, has a positive acceleration to start with, that means the ball is accelerating upwards and it will never come back down again. Why is that the case? Think of it like a rocket. Okay, when does a rocket have a positive acceleration? On Earth, when it has a thrust, when it has an engine, when it has some fuel boosting it upwards, blasting it upwards, then you're accelerating. Okay, like a plane. However, without fuel or without anything, hopefully the plane that you travel will not run out of fuel, or the rocket, then it will drop. Without fuel, the rocket will drop. So in here, we have to assume the ball, not assume, we have to let the acceleration of the ball to be negative to start with, because if it is not decelerating to begin with, if we don't make it negative in here, the projectile, the motion of the ball will be going up and never come back down. Like the balloon you bought as a kid. You lose your hand on it, it goes up to the ceiling of a shopping mall, and you never see it again. So anyway, so that's A is negative. Okay, so I'll put in here. Okay, it's always negative as long as the motion starts with going upwards. Okay, so remember this. If the ball of the motion starts by going upwards, it's always negative. Okay, because if it's not negative, there wouldn't be a motion coming back down. All right, so in here, we need three pieces of information to use Suva, and we've got our three, so we can use it now. So let's do S equals, oh, no, actually wrong formula. V squared equals U squared plus 2AS. V0, U is 12, 2 times A minus 9.8 times S. So that's 19.6. I bring the 19.6 S to left-hand side. So to left-hand side is negative, so bring left side positive, 144. Use a calculator or mental maths, 144 divided by 19.6. My mental maths tell me that the answer is 7.35 meters. Okay, around to two decimal places, or 3SF. Okay, that's the usual approach, convention of 3SF. Okay, part B. Find the total time before B returns to O. So part B, when the ball returns to O, that means we want to calculate a journey from O to O. Now you can also do, okay, or you can do O to G plus G to O, and then step a Suva both ways. But obviously, it'll be long-winded way, wouldn't it? So let's go O to O, okay, O to O. So Suva. Now, because we're measuring a different journey now, so we need a new different table. If you use O to G, you can use the previous one, work out a time in here, and then do a new table, work out time in here, add them up together. But O to O, so let's do that. So what's the displacement? From O to O, displacement is 0. Remember my McDonald's story. I left home for McDonald's and then came back home from McDonald's. My displacement is 0 because I went there for 10 meters, come back for 10 meters, 10 minus 10 is 0. Okay, so in here, because start and end at same point, that's why displacement 0. Okay, initial velocity is 12. The ball start off by leaving the point O at 12 meters per second. What about V? Is V 12? No, because we don't know what speed the ball drops back down to the point O. It's like you throw a ball upwards. Okay, the speed you throw the ball upwards might not be the same as the speed you catch the ball when it drops, right? So we don't know what's V. A, however, we know is negative 9.8, and T is what we're interested. So let's do that. So S equals UT plus a half AT squared. 0 equals 12T plus a half times negative 9.8 T squared. So 0 equals 12T minus 4.9T squared. You can put in a calculator, or if you like to rearrange it, feel free. I'm not going to do that. So minus 4.9 for A, 12 for B, and 0 for C. I put in a calculator. I get T equals to 2.45 or 0. Yep. So obviously we want the 2.45 seconds, and that's the answer. Okay. Let's look at the next one together. Example. A particle is projected vertically upwards from point O. From point O again. Okay. At u meter per second. The greatest height reached by the particle is 62.5 meters above O. So this is 62.5 meters. Okay. And then we assume the ball would come back down. Okay. Find the value of u. So part A, we're given nothing but from point O to point G, right? Greatest height, G. So point O to point G, suivant. We know S is 62.5, U is unknown, V is 0, A is negative 9.8. Okay, so we have enough information. So V squared equals U squared plus 2AS. V is 0, U squared is U squared. A is negative 9.8, S is 62.5. So 0 equals U squared. 2 times negative 9.8 times 62.5 is minus 1225. So bring the U over, square root. So U equals to 35 meter per second. Nice. Part B. Find the total time for which the particle is 50 meters above O. Now, before we start, I want you to think of this question. Can we use the same Suvat table in part A? The answer is no. Find the total time for which the particle is 50 meters above O. 50 meters above O, G, the point G is 62.5, so we cannot use the same point. So let's call this point A, okay, which is 50 meters. Okay, so we need a new point. We need a new Suvat table from O to A. Now, can I invite you to set up a Suvat table? Okay, pause the video, try to fill in the Suvat table. Okay, when you're ready for the answer, you can press play. So we know the displacement from O to A is 50. Initial velocity is 35 from part A. Final velocity, we don't know. Okay, final velocity means the velocity when it reaches A, which we don't know what it is. Acceleration, however, we do know is negative 9.8. They want us to find t. Okay, so there's only one formula we can use. S equals ut plus a half at squared. S is 50, u is 35, t is unknown, a is minus 9.8, t squared. You will see it's quadratic, so we bring everything to the left-hand side. 35t minus 4.9t squared minus 50. You can make everything positive if you want to, just flip the signs, but it's not required because you can put in a calculator and let the calculator solve the quadratic for you. So I put a is negative 4.9. Just one thing you make sure is the a value is the coefficient of t squared, not the 35. So it'll be minus 4.9 for me. And b is 35, c is minus 50. I put in a calculator. The calculator gives me two values. So t equals to 5.17 or 1.97. Okay, so which value do we use? Now, first of all, again, why do we have two values? Why do we have two values? So think of it. Think about a diagram. What does it make sense of the two values? Now, the two values because the ball, okay, first shoot from O to A, okay, and it goes to G, highest point, then come back down and passes the point A again. So these two values of T are the times that the ball crosses or passes through the point A. So that means if you think of it like a stopwatch, okay, we start recording time at 0, okay, and then we start the stopwatch, and then when it crosses A, we stop it once, and we got the first time 1.97 second. It reaches G, and then come back down again, stop the stopwatch again. Next time you see on the stopwatch is 5.17 seconds. So maybe you can think about how long was the ball or was the particle above O? So above the 50 meters line. It'll be this difference in the time between. It passes A at 1.97 second, and it comes back on at A at 5.17 second. That means surely the time in between will be the time that the particle has spent above A. So the final answer, okay? Therefore, time above 50 meters equals to 5.17 minus 1.97, which is 5.17 minus 1.97, which is 3.2 seconds. Okay, and that's the answer. Right, if you're happy with this, a little summary of a Suva. I'm going to skip this actually because it will be the same table as, oops, where was it? Is it page 15? Nope. Which page was it again? I can't remember. Will be same as similar to this one. So I'm not going to go for that. Okay. Right. If you're interested, you can write your own summary. Right. So have a go at practice question one. Okay. Pause the video and have a go at the answer. When you're ready for the answer, you can press play. Here are the final answers. Okay. Um, check your answer. I just want to have a quickly go at question C. This time the C asking you for the times the ball is 10 meters above the point of projection. So you don't have to subtract them because they want you to find the exact time it crosses the point. So yeah, they're not asking you for the time that has been spent. Um, oh, hang on, times is Oh, actually, I think there was a typo in this question. Should be find a time to the ball that is 10 meters. Oh, wait, actually, is 10 meters. No, no, actually, is 10 meters. That means is 10 meters. So it's 0.46 and 4.44. Unlike the previous one where they're asking you which the particle is the total time. So that's the difference. The total time is 50 meters above O. So that's the difference. Okay, this one is asking you for the times. So you can judge by the using the plural form of the word time. You can tell there are two answers. Okay, if you got it right, well then move on. Okay, if you don't, I'm go for the answer. Question A. So let's go for it. Okay, so again, we start in here. We'll come back down. So we start with the point. Let's say point O to point G again. Greatest height. So from O to G. Question A. Suvat. So we do know S is unknown. What we're interested initial velocity, we're told is 24. Final velocity is 0 because at the greatest height, velocity is 0. Acceleration will be minus 9.8. So v squared equals u squared plus 2as. 0 equals 24 squared plus 2 times minus 9.8 times s. So bring it to the left hand side. 19.6 6s equals 576. So 576 divided by 19.6 is 29.4. Okay. Part B. Find the time taken to reach this height. This height, I believe the question is asking about greatest height. So to find the time taken to reach this height, we can use the same Seebeck table to find t. So we can use v equals u plus at. V is 0, u is 24, a is minus 9.8. Bring it over. So 9.8t equals 24. T equals to 24 divided by 9.8, which is indeed 2.45 seconds. Okay. Question C. Find the times the ball is 10 meters above the point of projection. So we can just call this point A, okay, which is 10 meters. So we want to set up a different Suvat, this time from O to A. Suvat. S is 10 meters, U is still 24. Now V is no longer 0 because it's not greatest height. A is minus 9.8. And to find T, unknown. All right, so S equals UT plus a half AT squared. 10 equals to 24t plus a half times minus 9.8t squared. Bring it to your right hand side. 24t half times 9.8 is 4.9. If you do more mechanics, you will probably get used to the 9.8 times table. And minus 10, put in a calculator. Let me double check the answer. I put minus 4.9, 24 minus 10. Yep, I got t equals to 4.44 or 0.46. Yeah, so these two are the answers. Okay, these are times basically the ball crosses the point A. It crosses the point A first time in 0.46 seconds. As it come back down, next time it's 4.44 seconds. Right? Exam practice. Pause the video. Have a go with the question. When you're ready for the answer, you can press play. So here are the answers for part B and part C. Okay, so let's draw a diagram. Okay. In here, the ball. So being thrown vertically upwards at a point P, so that's the point P. Oops. That's what we're looking at. Okay. At a point H meters, so H meters, okay, above the ground. The ball hits the ground 0.75 seconds later. Let's call this point G. Just we can use the ground G for ground. Okay, so G for ground. The speed of the ball immediately before it hits the ground is 6.45 meter per second. So that's 6.45 meter per second. The ball is smaller as a particle later. Okay, show that u equals 0.9. Well, we're only told given 2 points, the point P and the point ground. So we just put P to ground. Okay, P to ground. Oh, I can't spell. So Ground. Suvat. Okay, question A. So S, we don't know. U, U is U. V, V, final velocity hits the ground is negative 6.45. Negative because if going up is positive, okay, remember this table in here, what was it? This one here. Going up is positive, then coming back down is negative. Therefore, okay, this negative, I'll show you in here, negative, okay, negative because opposite direction to up. Okay, so it's opposite traveling, it's opposite direction to up. Going up is positive, coming back down is negative. Simple. A, deceleration, negative 9.8. Okay, as the ball goes up, is negative. Okay, so now there's nothing to do with direction. I'll say again, acceleration being positive, negative has nothing to do with direction. Okay, the ball, whether the ball is essentially, the particle is essentially accelerating or decelerating, the ball traveling upwards has to be decelerating to begin with, therefore it's negative. Okay, time we're told 0.75. So we can use V equals U plus AT. V is negative 6.45 plus minus 9.8 times 0.75. So negative 9.8 times 0.75 is negative 7.35. If you add to the left hand side, you get U being 0.9. Okay, positive. Okay, nothing, no shenanigans about positive, negative. It's just positive. Okay, part B. Find a height point above P to which the ball rises before it starts to fall towards the ground again. Now, at this point, when they say the ball rises before it starts to fall towards the ground again, before it starts to fall towards the ground. So, which point is it talking about? It's this point. Okay, let's call this point A. So, the question is talking about this A, which is also the highest point. Okay, because it reached the highest point, then it come back down. So let's work out part, okay, part B. So we want to work out from P to A. Okay, from P to A. Okay, can we? If you got part A wrong, if you don't know how to do, if you just want to listen to part B, you can pause video anytime and you try to fill up a Suvat table by yourself. Okay, and you check your answer with me. From P to A, I know now U is 0.9. Now, exam technique, even if you can't do part A, you can still do part B because now you know U is 0.9. Okay, they give you U equals 0.9 just to give you a bit of security to help you answer the questions later so that not all the marks are lost because just because you can't do U. Okay, so U equals 0.9, so you can still use U being 0.9. Okay, for exam technique, for exam wise, if you can't do part A. So final velocity. A is the highest point, so V is 0. A is still minus 9.8. We are interested in the height. That means we're interested in S. So S equals, not S equals, I think we have used V squared equals U squared plus 2AS. So if you haven't remembered the super formula, do you remember the 5 of them? U squared plus 2 times minus 9.8 times S. So 0.9 squared is 0.81, so 0 equals 0.81. That's 19.6 S. Bring it to your left hand side. Divide 19.6, so 0.81 divided by 19.6, and you will get 0.04 meters. So let's read the question again. Find the height above P, which the ball rises. Yeah, so the ball has risen 0.04 meters. That means this part is 0.04 meters. Okay, so that's the answer. Part C, find the value of h. What's h? H is this length in here, this height in here. So how can we find h? Well, there are two ways you can do this, okay? Because that's considered journey, we now have 3 points, P, A, and G. To find H, we can either do from P to G or from A to G, and then you subtract 0.04. Now, how do we work out P to G will be the most straightforward, because if you look at the height from P to G, it's just H. Okay, so we are going to do this. Okay, part C. Oops, let's use it's the wrong color. So we want to do from P to G. Okay, let's substitute that. Now, from P to G, what's the displacement? Now, if the displacement going upwards positive, okay, then surely coming back down will be negative. So the answer from P to G, do you know what should we put in terms of H? It will be negative H. Now, why is it negative? Okay, you do want to write some notes in here if it makes sense to you. Because from P, okay, starting from P, okay, we are going a positive displacement, right? We're going positive displacement because we're heading towards A. Then, as soon as we pass A, which is the maximum displacement, which is 0.04, we start to come back down. That means we start to go back to direction where we started. That means we're reversing direction, therefore becomes negative displacement. So as from 0 going up to 0.04, and then slowly, okay, crosses A, then slowly the displacement reaches 0 at this point. It's like McDonald's. I left home, went to McDonald's, come back home, 0 displacement. As soon as I went back home, okay, reaches P, then I still continue to that direction, reversing direction. That means it will go further negative. Therefore, therefore P to G, the displacement is negative H. Okay, so I can write you a very simple line in here. It's negative because G is below P. Okay, the point G is below P. Okay, so that's why it's negative. Okay, so initial velocity, we know it's 0.9. V, we know is negative 0.65, is it? Negative 0.65, negative again. Okay, acceleration is negative 9.8. Now the sign do matter, because if you use the wrong sign, you can imagine when you rearrange the equation, wrong sign means you should be subtracting or adding, you did the opposite. So in here, we want to find S, so V squared equals U squared plus 2AS. V is negative 0.65 squared, U is 0.9 squared, A is negative 9.8, and S is negative H. So let's expand all the bracket. 6.45 squared is 41.6025. 0.9 squared is 0.81. 2 times negative 9.8 is negative 19.6. Times negative as well becomes a positive 19.6 H. So let me do 41.6025 subtract 0.81 and divide by 19.6 to make H a subject. You get H being a positive number, 2.08 meters. Okay. All right. So now, if for those who are wondering, how do we work up from A to G? I'll also show you for part C, but basically that's all you need. Okay, the main part is a negative H. So how do we work up from A to G? I'll show you as well. So for part C, alternative method from A to G. See that? Displacement from A to G, let's say it's just x meter. So the whole thing is just x meter. Okay, initial velocity, we start from A, 0, because A is the highest point. Final velocity will be 6.45. Now, why is it 6.45 but not negative? Because if we start a journey from A to G, there is no upward motion. Okay, if there's no upward motion, you can make it positive, or you can make it negative. It doesn't matter. Let's say we'll do negative. It doesn't matter. I'm going to stick with positive in here. A will be a positive 9.8. Positive because from this case, you're just accelerating, right? So actually, let's use, yeah, okay, so V squared equals U squared plus 2AS. V is 6.45 squared equals 0 squared plus 2 times 9.8 times X. So 41.6025 equals 19.6x divided over 41.6025 minus 19.6 will be 22.0025. Oh, nope. I made a mistake. So I clicked the wrong, press the wrong button. Should be 2.12. So 2.122. So therefore, h equals to 2.122, which is the whole, x is the whole distance. You have to take away the 0.04 in there, which is 2.08 meters. Okay, and that's the answer. And that's the end of chapter 9.